in amount of substance, the main thing you'll have to do in almost every single question is some kind of reacting moles calculation. All that means is if you can work out the moles of something in a chemical equation, you can work out the moles of anything else, any of the other compounds in that chemical reaction, by just doing the ratio between the big numbers in front of them in the equation. If you can't do that, you're going to struggle with all the other calculations. This is the bread and butter that you need to be able to do. Let's have a look at one of these questions. So we've got calcium phosphate reacting with nitric acid to produce phosphoric acid and calcium nitrate as shown in the equation below. That top sentence and the equation say exactly the same thing. They've been nice, they've balanced the equation for you. So that top bit is just saying what's going on. It's important, make sure you read it, but it basically says the same as the chemical equation. So then we've got 7.26 gram sample of calcium phosphate. That's our first bit of information. Let's annotate it. So let's underline that 7.26 grams. And it says it's of calcium phosphate, so let's underline the calcium phosphate in the same colour. Everything underlined in blue will be referring to calcium phosphate. So it reacts completely when added to excess nitric acid, which is the HNO3. If you've got something which is excess, that means the other thing must be limiting, and it's the limiting one that you always use in the calculation, because that's the one that will get used up, and that's one that controls how much will be made of anything else. So our calcium phosphate is limiting, we know how much of it there is, that's the one we're going to use in the equation. So it's added to this excess aqueous nitric acid to form 38.0 centimeters cubed of solution. It doesn't tell you what solution we're forming. It doesn't say 38.0 centimeters cubed of what. You have to think about that yourself. So calcium phosphate is reacting with nitric acid. So that 38 centimeters cubed is going to be of this phosphoric acid and the calcium nitrate solution. Calculate the concentration in moles per decimeter cubed of phosphoric acid. So again, this is the volume of phosphoric acid. It's 38. We've got it in the equation, underline it all in red, and we'll give it to 3 significant figures. It doesn't matter if also in that 38 centimeters cubed there's a bit of calcium nitrate, because we're going to care about the moles of phosphoric acid. So let's do the calculation. So first thing we need to do, we're trying to work out calcium phosphate, but at the moment we only have a volume, no other information about it. And the only other chemical we have any information about is the calcium phosphate, which we know has a mass of 7.26 grams. Let's think about what our 2 equations that we could use here are. We know we've got moles equaling mass over molar mass. And we've got concentration, I'll just write conc, equals moles over volume. So there are 2 equations. We are trying to work out concentration, and we know volume, but we don't know number of moles. So is there a way to work out moles? Yes, using the first equation where we know mass, but we don't know the molar mass. So if we don't know the molar mass, let's work it out. We've got the mass of calcium phosphate, so we need the molar mass, which I always write as a capital M. And I write down what we're working out of as well, just to make sure your work is nicely labelled. Ca3PO4 twice. That's going to be 3 times the mass of calcium, because we've got 3 calcium ions in the calcium phosphate, plus 2 times, and this is the little 2 outside of the brackets, 31.0, because that's the mass of phosphate, plus 4 times the mass of oxygen, because it's PO4. And because it's twice, we've got 2 of them. And that's going to give you 310.3. Now, the important thing here is, now we know the molar mass as well, so we can work out the moles of calcium phosphate. So let's do that. Number of moles, I'm going to write as an N, and again write what we're doing it of, just so the examiner knows exactly what you're doing. It's going to be mass, 7.26, divided by the molar mass, and that gives you 0.0234 moles. And that is the moles of your calcium phosphate. But what we want to know, to put it into the second equation, is the moles of the phosphoric acid. So now we have to look at the equation and look at the ratio. There's nothing in front of the calcium phosphate. That means it's a 1. In front of the phosphoric acid, there's a 2. And that means the ratio that we care about, the calcium phosphate to the phosphoric acid, is going to be 1 to 2. So the moles of the phosphoric acid, the H3PO4, is going to equal that 0.0234 from the calcium phosphate multiplied by 2, because it's a 1 to 2 ratio and 2 is twice as big as 1, so you're timesing it by 2. That gives you 0.0468. So now we also know the moles of phosphoric acid, so we can work out the concentration. And we know the volume because it is that 38.0 centimeters cubed, but we don't want it to be in centimeters cubed. We need it to be in decimeters cubed, so divide it by 1,000. And that will give you 0.038 decimeters cubed. So then your concentration of the phosphoric acid, which we'll call C, is going to equal number of moles, 0.0468, divided by the volume, 0.38. That will give you 1.23 moles per decimeter cubed. And we have to add to 1.23 because it even says in the question to 3 significant figures. But every other number in the question is also given to 3 significant figures, so you should give your answer to 3 significant figures anyway. Now this question was worth 5 marks. If we look at where those marks are from, 1 for working out the molar mass, second of all for working out the moles of calcium phosphate, third one working out the moles of phosphoric acid using the ratio, fourth one converting centimeters cubed into decimeters cubed. You normally get a mark for converting, so make sure you do it, and the fifth and final mark for the final answer. So this question was just a reacting moles question where you had to use the ratio, but this is quite a nice example because you use both moles equals mass over molar mass and concentration equals moles over volume.